So hey guys, welcome to my channel. My name is Ayush Kumar Rana. Currently, I'm a BTech undergrad student, and I'm going to teach you chemistry. And in today's video, I'm going to teach you surface chemistry. Okay, so surface chemistry. So what surface chemistry? Basically, this is just a study of interfaces between two surfaces. Okay, right. So let us now jump to the most important part of this chapter, which is adsorption. Adsorption. So what adsorption is? Like this is the phenomena of higher concentration of adsorbate molecule on the surface of adsorbent. Absorbent. Okay. Like example, SiO2, silica gel. What it did is like this is the surface of SiO2 silica. And like these are the water droplets present in the atmosphere. What it did is like it extracts water molecule from the atmosphere and accumulate here on its surface water, okay? So that it prevents your gadgets and your medicine from moisture so that they can stay for a longer period of time. Okay, so let us now talk about absorption. What is absorption? This is also a phenomena of higher concentration of molecules inside the bulk. Inside the bulk. Like what happened in this is like this is the surface. Okay. Like those in adsorption, the molecule stays over here on the surface. But here in this, the molecules penetrate inside and they are present inside it. Okay, like this. They does not present over here. They just penetrate into the bulk and just present over here. Okay. And now let us discuss about like I have to give example first. Example is example example is CaCl2. Okay, like it absorbs the moisture. It absorbs the moisture. Now let us discuss about sorption. When this adsorption and absorption occur simultaneously, then it is called as sorption. And there is one more term, desorption. So what it is like this is is just reverse of adsorption. Like here, molecules detach from the surface. Okay. So let us now talk about types of adsorption. There are two types of adsorption. First, physical adsorption. Physical adsorption. And second is chemoabsorption. Chemical adsorption. So what these two are, like here, this arises due to weak van der Waal forces. Okay, but this chemical absorption, these are sorry, this occur due to strong chemical bond. Right. So this is it for physical absorption and chemical absorption, a basic overview. Okay, so let us now discuss about some more examples, like differences. I'm going to say differences between physical absorption, physical absorption, physical absorption, chemical absorption, absorption. Okay, okay. So one side physical absorption, here chemical absorption. Okay. Let us now discuss about some examples. Okay, number one. So this is this arises due to V van der Waal forces. Okay. And here this arises due to strong chemical bond. Okay. And second is it is multi-layered absorption. It is and then chemical absorption. It is unimolecular, unilayered. Okay, so like the monolayered absorption. That is heat of absorption is low in physical heat of absorption. Absorption is low. Okay, and in this heat of absorption is quite high. Like in this is from minus 20 to -40 kilojoules per mole. And here it is like -80 to 240 minus 240 kilojoule per mole. Okay. So there are some more differences. The fourth point is energy of activation. It's not required. Here, energy of activation is required. Required. And these are formed by the chemical bonds, and to proceed a chemical reaction, we obviously need some energy. So this is why we need some amount of energy of activation. Okay. And the fifth point is reversibility. So in physical absorption, these are reversible in nature. Reversible in nature. And here, these are irreversible in nature. Obviously, you know that a strong chemical bond form here. So irreversibility is reversibility is near to impossible. These are irreversible in nature. And the sixth point is temperature dependency. So in this, absorption decreases with increasing temperature. Temperature. Okay. But here, first, absorption increases with increase in temperature, and then it decreases with increase in temperature. Okay, I'll explain you in a bit. Okay. Now the seventh point is these are not specific in nature. Okay. But these are highly specific in nature. So let's come to the sixth point. So what happened is like I'm showing you through the graph. Its graph is somewhat like this. Okay. So as the chemical bond formed, it required some activation of an energy of activation. So the amount of activation of energy is provided EA. Okay. So till EA is attained, then the absorption is increases gradually, and after attaining EA, then it decreases gradually. Okay. So this is like that is now talk about factors affecting absorption of gases on solid. Factor affecting absorption. Oh, yes. On solid. So first point is like nature of gas. Basically, what it means like the gas, the gases which are easily liquefied, they absorb at more extent, and those gases which are not liquefied easily, they are absorbed at less extent. Okay, so the gases which are easily equiable, absorb at more extent. Like example are CO3, CO2, SO2. Okay. Like, the gases which are not easily occupied, absorb at less low extent. Examples are H2, M2, argon, air, helium, etc. So let us now talk about this second factor, which is nature of the solid. Nature of the solid. What it is, and like physical absorption does not depend upon the nature of the solid, but in chemical absorption, they are highly specific by their nature. So the greater interaction between the adsorbate and absorbent, then the extent between adsorbate and absorbent will be more, then the absorption will be higher. Okay, like I will write it and you'll understand it better. Okay. It does not depend upon the nature, nature of solid, but chemical absorption highly specific in nature. So in nature, okay. So the greater the interaction between absorbent, adsorbate, and adsorbent, adsorbate, the extent, then sorry, more then so the interaction between adsorbent and then the extent of adsorbent. Sorry, my bad. I've written the interaction between adsorbent is more than the adsorption will be higher. If the interaction between adsorbate and absorbent is low, then automatically the adsorption will be low. Okay. So like example I have to give Fe adsorbs, Fe adsorbs N2 and S2 on its surface. So another factor is nature, nature of solid. So physical absorption does not depend on nutrients, but as chemical absorption, highly specific by nature. So greater interaction between absorbent, absorbate, greater extent of absorption release. Example, F absorb H2 and N2 on its surface. Like now, the third factor, which is the most important according to me, is like surface area. This is just very important. Okay. Greater the surface area, greater will be the absorption. Okay. Like I have this much small and this big surface. So the extent of absorption here is more rather than this surface. Here less. Okay. Here more. Sorry, more and here less. Okay. Now this fourth point comes to the table. Temperature. Temperature. Yeah. So physical absorption decreases, but chemical absorption once increases and then decreases. So increase in temperature. I'll explain this briefly in some time. Okay. Just write this for this time. The pressure. You have to write it. Correct. R-E-S-S-U-R. Okay. Pressure on increase the pressure in the pressure on increasing the pressure extent of absorption increases. to a limit, up to a limit. After that, it became constant. It became constant. Okay. So here I'm going to discuss adsorption isotherm, which is the most important part of this chapter, according to me. Okay. Okay. So let's discuss the most important topic of this chapter: adsorption isotherm. What is adsorption isotherm? This is nothing just this is the relation between strength of adsorption and pressure at constant temperature. As the name depicts, isotherm. Iso means same, and therm means temperature. Okay, so this is isotherm. So the relation is like this: x by m is directly proportional to p to the power 1 by h. Okay. And this somewhat looks like this: equals to k p to the power 1 by n. So here x by m whole is exponent of adsorption. Yeah. And x is amount of adsorbate. M is mass of adsorbent. Okay. And this k is constant. And this p is pressure. Yeah. So I have drawn this graph to show you like, to how it's very like first it increased like linearly and then it increased exponentially and then it just became constant. Okay. So what is this? This is saturation pressure. What is saturation? Like after applying this much pressure, the graph became constant. There is no more extent of absorption. Like absorption stops here at this pressure. Okay. After this, no further adsorption happens. Okay. So let us now discuss this mathematically. Okay. Mathematical pressure. Okay. So you have to remember some key points. At low pressure, then the value n is equals to 1. That is from here n equals to 1. Okay. At medium pressure, n will be 2, 3, 4, or might be anything. Okay. From here to here, this is moderate pressure. Okay. This is high pressure. High. Here n equals to 0. at high pressure n is equals to 0. So according to the expression which I shown you in the previous slide, that is x by m is directly proportional to p to the power 1 by n. Okay. So according to this, uh, we can say for the first case, first one, uh, x by m is directly proportional to p to the power 1. Okay. And for the two, we can say x to the power m is directly proportional to p to the power 1 by n. N equals to where n equals to 2, 3, 4. According to 3, x by m is directly proportional to p to the power 0. Okay, so how can we write this mathematically? So to write it mathematically, we can say that x by m is directly proportional to p to the power 1 by n. Okay, and x by m is equals to k to the power p by 1 by n. Okay, 1 by n. This is one. Okay, so let us now take log both side. Log x by m equals to log k plus 1 by n log p. As you have already studied log properties, this power and came in front of log. Okay, so let us now reorder this. Log x by m equals to 1 by n plus, sorry, log p plus log k. This is the right expression. Let us now compare it by y equals to mx plus 2. So m equals to 1 by n. This is the slope of the graph. Okay, so let us now drop the graph. This. Here we take log x by m. Here we take log p. Here we take log k. As this is the log k is the intercept. Here you can see C. C means intercept. Okay, so this is the intercept. Here the graph started. So the slope of the graph is slope equals to 1 by n. Okay, this is the slope of the graph. And one more thing, as the temperature raises, the extent of absorption decreases. Okay, sorry, like T1, T2, and T3. So, like T3, T2, and T1. Like T3 is at lowest temperature, so it absorbs more. Okay, sorry. I just spoke wrongly. As T3 temperature is very much and T1 temperature is very low. So at T1 temperature, the extent of absorption is very high, and at T3, its extent of absorption is very low. Okay, so let us now talk about some application of absorption. Absorption. First, to control humidity. Okay. Second, used in gas mask. Okay. Third, in dyeing the clothes. Fourth one is production of vaccine. Production vaccine. Yeah. Fifth is to clean a solution. Okay. So this is it from my side today for today. And Till then, be safe, be sound. See you in the next lecture that will be uploaded tomorrow. See you. Take care. Bye bye.